in the final multiple choice question, question 4, we see that we push a heavy refrigerator across a floor at constant velocity. So that means that there's no net force. And yet we're pushing with 500 newtons. So that must mean that there's something opposing that push. Then your friend joins you, allowing you to push the refrigerator at 1,000 newtons. So later, your pushing force equals 1,000 newtons. And we're asked which of the following statements is true. So if we're now pushing harder, is the force that is pushing against us, that before was allowing this refrigerator to be going at a constant velocity, is that force going to increase or is it going to stay constant? Well, this force is likely due to the force of friction, force of kinetic friction, which is constant. Through a good approximation. Okay, so let's read what we're asked here. We're asked to determine which statement or statements is or are true. So here we have multiple possible correct answers. Before your friend joins you, the net force on the refrigerator was 0. Now these are different tenses. This grammatically should have been is 0 or joined you. Before your friend joins you, the net force on the refrigerator is 0. Yes, the net force on the refrigerator is what causes us to accelerate or not. Any net force would give us a non-zero acceleration. Constant velocity means we have a 0 acceleration, so the net force is 0. Before your friend joins you, the kinetic frictional or resistive force was equal to the force at which you pushed. Well, we had a force that was we were pushing at 500 newtons, but we had a net force of 0, so something was pushing against us. Whatever that was adding up to give you 0. So the frictional force was equal to that force which we pushed at least in magnitude. After your friend joins you, the net force on the refrigerator was 0. Well, if our opposing force doesn't change, then the net force on the refrigerator will not be 0 because we're pushing harder, but the force is pushing against us is not pushing harder. But the refrigerator moves twice as fast. Well, if the net force is 0, that means that is not 0, and that means that this statement is already wrong. After your friend joins, the refrigerator accelerates with a constant acceleration. After your friend joins, 1,000 newtons is pushing forward, 500 newtons is pulling backwards, which means that we have a net force now, which means that we will have a constant acceleration. After your friend joins, the refrigerator accelerates at twice the acceleration it did with you alone pushing it. Well, we have F net equals ma. Initially we had a equals 0. And finally, a is not equal to 0. And twice 0 is not something that's not equal to 0. So this answer is incorrect as well.